Hello and welcome back to See the Pattern. Over the next few episodes we will be focusing on our Sun. We will examine the current model and understand what the limitations of this model are. We will then turn our attention to an alternative electric model and how this could overcome these limitations. And finally, we will take this understanding and apply it not just to our Sun, but to stars in general, and explain some of the anomalies that we have observed to date. In this episode we will be focusing on the current model. In this model, the Sun is a ball of gas consisting mainly of hydrogen and some helium atoms. The ball of atoms is large enough that gravity not only holds it together, but causes the atoms close to the centre to experience extreme pressures and temperatures that cause the atoms to begin to fuse together. If unchecked, the whole mass of the Sun could continue an inward fall, creating a runaway fusion reaction. As the atoms fuse together, the radiation and energy release creates an outward pressure which halts this collapse. The star reaches a happy medium where the inward pressure is balanced by the outward pressure. The core is where the nuclear fusion takes place. Surrounding this core is a radiative zone, which transports the energy outwards via photons. On top of this is another zone which carries the heat to the surface via convection columns. Now it takes the photons about 100,000 years to travel from the core to the surface of the Sun. The surface of the Sun is called the photosphere. This is the surface we see with visible light. About 2,000 kilometers above this sits the chromosphere and glows faintly red. Even further out sits the corona, which is visible during solar eclipses, and even further out is what we call the plasmasphere, which stretches out as far as Pluto. So the first problem we come across in the standard model is the structures that we see above the normal surface of the Sun. Now in the standard model it's based on the idea that gravity and nuclear fusion cause all the effects that we see. The problem with this model is that it cannot explain the chromosphere, the corona or the plasmasphere. These structures simply should not exist if this process is driven by nuclear fusion. Heat and light should simply radiate away evenly in all directions from the surface of the Sun. And as you move further away from the surface of the Sun, the temperature should steadily drop in this model. This is, however, not what happens. As you move above the photosphere, the temperature does indeed start to drop from about 10,000 to about 5,000 Kelvin. But then something odd happens. The temperature starts to rise as you approach the chromosphere, and as we reach the corona, the temperature shoots up to over 1 million degrees Kelvin, and in fact can reach temperatures as high as 3 million Kelvin. Now the standard model has no explanation for why this should happen. The third problem is the solar wind. The Sun emits ions via the solar wind. If these were produced via nuclear reactions, this stream would be expected to be very constant. The fusion reaction at the core does not vary at all if we assume this model. But in fact the solar wind varies greatly and has even been known to stop entirely for a whole day. The other strange fact about the solar wind is that you would expect these particles to slow down after being released by the Sun. But in fact what we see is that the particles accelerate away from the Sun and gain speed as they journey outwards. The next problem are sunspots and sunspot cycles. Now we know that sunspots on the surface of the Sun vary within an 11-year cycle. The standard model cannot easily explain sunspots, let alone the cycle, but it attempts to do this via magnetic field lines that become twisted as the centre rotates at a different rate to the poles. Now this 11-year cycle is just a cycle within another cycle. There is what they call the Gliesberg cycle, which is an 80-year cycle where we see temperature variations in our records, both short-term and longer-term, looking at tree rings, and that then sits within an even larger cycle called the Grand Minima Grand Maxima cycle, which takes approximately 400 years and takes you from an extreme low to an extreme high. And the effects that we know from this are that they can change the temperature, and in fact at the previous low that we are aware of, called the Maunders minimum, we had what is termed like a mini ice age. So the effects on the climate are palpable. So what exactly are sunspots in the standard model then? They are described as being areas where the magnetic flux blocks the convection currents and therefore cause the temperature to be lower, and it's about 2000 degrees lower than the photosphere. Now, if these magnetic flux lines are indeed holding back the convection currents, we would actually expect to see the plasma being trapped within the magnetic field lines, but we don't see that at all. Now, looking at the images of sunspots, to me it looks more like parts of the surface of the sun have been removed, and what we're actually seeing is down into the internals of the sun itself. The final problem are granulations. When we examine the surface of the sun, we observe what are called granulations, and they are described in the standard models as the tops of the convection columns. Now, the problem is that these columns are way too stable to even exist. The only way to get these columns to exist would be if the plasma flow upwards was in laminar flow, meaning that they would rise up in a steady column. Imagine creating a fire and expecting the smoke to rise in a straight column. What would happen most of the time is that the smoke would end up in a turbulent flow. It is possible to calculate if a fluid would either be in laminar or turbulent flow, and both the temperature and the viscosity of the plasma would mean that it is not possible to have laminar flow on the sun. So we've seen 5 good examples of why the current model does not work. The first one being the structures called the chromosphere and the corona shouldn't exist in a fusion-based model. The second one, the fact that the temperature rises from the chromosphere to the corona, makes no sense. The third one being the solar winds, the fact that it's variable and the fact that the particles accelerate even after leaving the surface of the sun. The fourth one being sunspots and sunspot cycles, and then lastly the granulations on the surface of the sun. In part 2 we will examine a much better model for our sun, which could explain all of these anomalies plainly and simply. As always, follow the evidence, be brave, be curious, the truth is waiting for us. Until next time.